the third little video tutorial in the myNewImagePicker app, how to write the app. It's available on the App Store, free. What this app does is drop little sprite kind of candy down from the screen. Take a look at that, right? Here's the app built, 5 pictures down the screen. You press the play button, you can drop the pictures into the screen, and they bounce around. They do some nice little emitter node stuff. That's part of for a different tutorial. We take a look at today, we make a spray, and that spray colors a little colored sprite nodes drops down from the screen when the user presses this button here. Okay, let's see how to do that spray. So we have a little function here, a little method called mySpray, and what mySpray does is it makes those little color sprites. It declares 15 color sprite nodes, right? Color sprite 1 through color sprite 15 here, and initializes them to be different colors. Sprite 1 is red, and it's made of my color sprite size, so 10 by 10. So all the sprites are 10 by 10 little squares. You remember seeing them bounce around. They're all made with this convenient method, sprite node with color and size. So pretty easy, but you need to know that the colors are UI colors, and all those UI colors you can see in uicolor.h. Okay, that's where I grabbed them from. And then they're all the same size. I want them all to look the same, like little candy, little eye candy. So they're all set with my color sprite size. I want to make a bunch of them, or at least more than one of them at a time. So we do it in a loop that's my color sprite loops. And that's defined up at the top here, my color sprite loops, so 3. And we're going to run this loop while it's less than color sprite loops, so it's going to do it only twice. And it'll sort of make 15 and make another 15. So after it declares the sprites, or Alex, and inits them, we have some sprite objects to work with. It positions the sprites. And I want to position them all across the top of the screen so that color sprite 1 is at max Y. Max Y is the top of the screen. And it's offset from the middle of Y. And so this way, depending on different, devices, we're not going to, we'll at least be in the center, put it that way. We're offset from the center. So our first sprite is offset in the X, right, in the left, right, by 175, minus 175. And then notice here that each sprite is offset by 25 points less until we get to the middle sprite. That's right in the middle of the screen, get mid-X, CGREC get mid-X. And then the sprite's offset over to the right. Now take a look at the way we specify the position with a CG point. And so we use a CG point make function, and then as its parameters we supply the CGRect, we call a CGRect function and ask CGRect to give us back the mid-X value of our frame. And we add the offset number. And then for the Y parameter, we're getting the max value of the frame. And it might be faster to get this value here up at the top and not keep asking for the value each sprite. We can improve that in the next version of the code. So let's move down here to the next real interesting point, which is a physics body. A physics body is something that you assign to a sprite that lets it bounce around in a scene, or lets it interact with gravity, lets it interact with forces, basically lets it participate in a physics simulation. And that physics simulation, that's all part of SpriteKit. And you can learn about that. It's all for free by declaring physics bodies and applying forces to the sprite. So let's take a look at it. In each case, we're going to apply a physics body that's the size of our sprite. Okay? That's it. So that's going to make sure that it interacts, according to its size, interacts in the scene according to its size. In the next block of code, we're going to say that the sprites are affected by gravity by declaring that their physics bodies are affected by gravity. Okay? Now, in all of this code, in the same thing with the next line of code, the next block of code where we're setting restitution, we're setting parameters on the physics body of this that we're going to later apply to the sprite. Or that's going to be worked with the sprite in the physics simulation. Okay? That next block of code, restitution, says that those sprites will bounce around. They'll have a certain bounciness. That may be the... Anyway. And I believe by setting that restitution much less, a little bit less than 0, you cause the sprite not to bounce back to its initial location. And the higher you set it, the more force gets added to that sprite each time it bounces around. So eventually it just bounces its way right out of the scene. In the next case, we're setting the blend mode of the sprite. Blend mode is something we can look into separately, but there's a bunch of different blend modes that are more or less efficient and make the sprite interact with what's on the scene in a different way. Because these are color blocks, I just want them to replace whatever's on the screen. We're naming all the sprites so that we can work with them later and remove them if there's too many. And that'll be part of another tutorial. We're setting a contact test bit mask on all these sprites, physics bodies, so that we can then determine when the contact happens. And that'll be part of a different tutorial. When that contact happens, what to do. So SpriteKit will tell you when different sprite nodes contact each other, and we want to do different things when our colored sprites hit stuff than when our picture sprites hit stuff. Okay? Then we add our color sprites to the scene, and then we're going to give them an action, which is to let them rotate a little bit, wait for a little bit, 5 seconds. That's what that's what wait for duration does. Waits that number of seconds, and there's a range there, so it'll wait, some of them as little as 3.5 seconds, some of them as much as 6.5 seconds. Put a little variability in there. Back to that first action, rotates by angle, and so that'll rotate the sprite by the angle pi. Pi is defined in math, right? We know about pi radians, all that stuff, the math people. The actions themselves we'll go into in more detail, but any sprite actions can be applied to it. We need to do these actions so that the sprites don't stay around forever, which they would. Our last action is to remove it from the parent. So we tell this color sprite, we declare this action, we call it myColorSprite action. We declare this action to be a sequence of actions that's going to rotate, then wait, and then disappear. And then we run the actions on all of our sprites, right? Color Sprite 1 through Color Sprite 15, run action. Now, back up above a little bit, you see we add the sprites to the scene here, right? So each color sprite that we declared gets added into the scene right here in this add child method. Add child is the method that you use to bring child nodes into this SpriteKit scene, SK scene, that we're running in here. And so we're adding our little children, our children that we just created, and that's it. And then these things start bouncing around and act according to our sequence. Let's go back to the simulator and look at this. When we press that spray button, we'll let our sprites bounce around. They bounce high because of that restitution value, and they stick around for around 5 seconds because of the action that we told them to do, to wait for duration before being removed from parent. Okay? When we first drop the sprites from the top of the screen, they turn a little bit. They take a little bit of a spin, and that was that rotate by pi action. Let's take a look. Okay, the action that happened on each of the sprites is right here. Rotated, we waited, and we removed from the parent. Now that we bounced around because we set a restitution on those sprites, if we set the restitution to 0 and run again, those sprites, well, let's see what happens. See, they're still affected by gravity, but they just stay on the ground because we're telling the physics simulation here, the SpriteKit engine, that these things have no restitution. They don't go back to where they came from. If we set the restitution higher than 1, the sprites bounce around pretty radically. And we set it to 1.5 to take a look. So they'll bounce back past where we dropped them from, and then each time they hit the wall, they keep getting more and more force until they just get blasted out of the scene. I'm not sure if they're supposed to get blasted out of the scene, or that's because we're not tracking them carefully enough. You can tell these sprites to be tracked a little bit more carefully. That's part of a different tutorial. Okay, so that's it. That's how we make these color sprites and add them to the scene in myNewImagePicker. All right, thanks for watching.